All right, so this one gives us a value for KSP for chromium iodate, and it wants to know what the molar solubility of the compound is. So this molar implies that I probably need something that's in terms of moles per liter, which looks a lot like a concentration. So I bet if I solved for the concentrations inside of the KSP value, that I would have the correct answer. So let's go ahead and write the equilibrium equation for this. Iodate is IO3 minus, and that's a chromium 3. So we probably need 3 of those guys. That happens to be a solid because it is a salt. When it dissociates, it's going to dissociate to chromium 3 plus and 3 iodate anions. And both of those are going to be soluble in water. Now, if I write the KSP expression for this, I'm going to end up with chromium 3 plus iodate minus cubed, because I have to take that coefficient of 3 into account. Now, if I set up an ice table, I don't care about the solid because the solid is not included in the equilibrium constant expression, so I can ignore the whole reactant sign. But if I set up an ice table starting here, I can say that initially I didn't have any moles of that because the solid hasn't been allowed to dissociate into ions yet. So those guys must be 0. When this changes, it's going to change by a factor of S because there's 1 chromium for every of those chromium salts. And this actually changes by a factor of 3S because there's 3 iodates for every 1 mole of that chromium salt. So at equilibrium, I have an S and I have a 3S. Now it's really important that you be able to visualize this, and if you don't need the ice table, that's okay. But you need to visualize that 3S because when we go back and we plug it into this expression here, the S for the chromium 3 plus is easy enough. This 3S for the iodate anion is really, really important. It's extra important when I have to cube it. Now remember, you have to do both. This is a mathematical operation. Multiplying 3 times S is just how we get the concentration of iodate ion in solution. So you have to take the 3 into account here. This 3 that's found in the KSP is part of a different mathematical expression. It comes from the stoichiometric coefficient, just like the 3S, but it's a different mathematical operation. So they both have to be taken into account. Now, if I were to simplify this, I would have KSP equal to, and I don't want to combine it yet for you, this is still just the chromium 3 plus. I have to remember to distribute that cube out to everything. So I end up with 9S cubed, okay? That's different than it could be elsewhere. So make sure that you know you distribute this out. It's pretty common for students to put 3S cubed there, and they only cube the unknown variable. So if I want to simplify it even further, I'll end up with 9S to the 4th. And I know that KSP value because it's given to me up here in the problem, so I'll just go ahead and keep filling in my answer there. So divide that KSP by 9, take the quartered root of it. I don't even know if that's correct, and it's probably not. But in your calculator, you will type in the caret sign and then to the 1/4 power. That gives me a value of X of 0.0273 molar. This happens to be concentration of chromium ions in solution. Whoops, that should be an X because that's what S is. The iodate anion is actually 3 times that, or 0.0189 molar. And now I have figured out everything that I need. Now this is also for the salt, just so you know, which is actually what the question is asked for.